Looking a little bit at algebra tiles lately, and we're going to sort of put some of these pieces together, adding, subtracting with them, and writing expressions with them to actually start solving some equations. And these are, again, going to be, I'm using simple equations. And you can do this with obviously much more complex equations, but it really helps to give you a better understanding of what's happening in an equation. So our first equation we're going to start with is x plus 2 equals 5. Now I'm going to use the same thing that I've been using in the last few videos, where a blue tile is going to represent a positive 1, a red tile is going to represent a negative 1, and then a blue rectangular piece is going to represent x. So I'm going to show x plus 2 equals 5. So I'm going to start by putting our x, right? And then I'm going to add 2. I'm going to put a little sort of equal sign in between, and then put what goes on the other side, which is 5. So I'm going to take 5 of these pieces right here. Now you can probably look at x plus 2 equals 5 and know with just some simple number facts that 3 plus 2 equals 5. So x is going to equal 3. But we're going to show how you can do that with tiles. So I have this equals this. Now, whenever we're working with equations, we always want to think of it like a balance or a scale. So I've got one side and the other. And right now they are equal. If I do anything to one side, then I would have to do the same to the other side, or else it's not going to be equal. And when we're solving equations, we want to do something called isolating the variable. Isolating the variable means we want to have the variable just on its own. So at the end, when I solve this, I want an x on one side and a number on the other side. And the only thing I want on that one side is just an x. So I want to get rid of anything that is not an x. So if I was to remove 2 of these, this is no longer an equal equation, right? If we're thinking of this like a scale and I remove 2, all of a sudden this side's a lot heavier because I took off the weight. But if I do the same thing to both sides, if I remove 2 from both sides, 2 from here and 2 from here, my scale is now even again or equal. And what we see left is what the answer to this equation is, which is x equals 3. So again, we're just using this rule of thinking of how equations work and things are equal. And if I do something to one side and then I do the exact same thing to the other side, this scale is going to stay the same. These things are going to be equal. So this shows us x equals 3. All right, let's try another equation. If we had x minus 2 equals negative 1. Now I'm going to start with my x. I need to subtract 2. Now, when you're showing minus 2, you kind of have to think about this also as the same thing as x plus negative 2. Okay, this means the same thing. Subtracting a positive is the same thing as adding a negative. So when I visualize this, because I can't really take away 2 from this side if there's nothing to take away, so I'm going to put 2 negatives here, which means x minus 2. And on the right side, I'm going to put equals negative 1. So now I want to solve this. I want to remove anything on this side, so I isolate the variable. However, if I am isolating the variable, I have to do the same thing to both sides. So if I take away 2 negatives, right, that's not really, I can't really do that because I can't take away 2 on the right side. So we can use that principle that we had before, where if I know if I have a plus and a minus, a pair, that equals 0. And I can actually, when we're thinking about keeping the scale equal, if I add a 0 to a side, that actually keeps it equal because I'm not really adding or subtracting anything. So if I want to take away 2 of these negatives, I could add a pair over here. And now, if I remove 2 from this side, my scale is not equal, so I will also remove 2 from this side, and I get an answer. And this answer is just simply x equals 1. And that means that 1, so x equals 1. If I replace x with 1, 1 minus 2 equals negative 1, or 1 plus negative 2 equals negative 1. So that is true. Okay, we're going to look at another one that we can do, and that is something with some multiplication. 2x equals 6. So I'm going to take 2 of these, and then I'm going to add 6 of those pieces over here to the other side. Again, you can probably look at this and know right off the bat that what number goes in there, 3 is going to go in there and make that true. But this is how we can see this. We want to split this in half, right? We can see that both sides, if I split this side in half, then it's then I'm going to have just an x. I will have isolated the variable. And I can also split this side in half. So if I was to remove half of this side and half of this side, my equation stays equal. My scale stays balanced, which shows us that x equals 3. And so that really shows dividing. We divided both sides by 2, and I removed half from each side. So we can also use these algebra tiles to show division. Finally, if we had something like this. Now you notice this time the number is on the other side of the equation. That's totally fine. It's not going to change how we solve this. Just at the end we might have our x on the right side. We'll still get x equals something if we read from right to left. So I'm going to do 4 equals x minus negative 2. 1, 2, 3, 4. And then I'm doing x minus negative, oops, sorry about that. And then I'm going to do x minus negative 2. So I can have this right here. Now, I can't really show taking away negative 2. But what I can show is, remember, that, like before, how we noticed that subtracting a positive is the same thing as adding a negative. We could also rewrite this as 4 equals x plus 2. Okay, if you're taking away negative 2, then that's the same thing as adding 2. So I can just add 2 right here. Now I can remove 2 from the right side because I want to isolate the variable. Remove 2 from here, do the same exact thing on the other side, and we see that we wind up with x equals 2. Even though we're going from this side to that side, it doesn't really matter. It means the same thing. I could say x equals 2, like that, or 2 equals x, or x equals 2. They mean the same thing. Both of these should be answers that would count just fine. Okay, so we can see we're really using algebra tiles to start to solve some equations, okay? Yeah. Okay, so we're going to look at one more type of equation, or one more equation. Here's 3x plus negative 1 equals 2x plus 4. So this time we have x's on both sides of the equation. Again, we follow the same process. I'm going to put 3 x's on the left side, okay, plus negative 1. So I'm going to drop a negative 1 over there as well. Put it up here, sure. All right, and then on the right side, we're going to do 2x plus 4. So I'm going to put a x right here, another x, and then I have to add 4 positives. 1, 2, 3, 4. Okay, so we got a lot of stuff going on over here. Kind of taking over the page. We got 3x plus negative 1 equals 2x plus 4. So to solve this, we want to start to isolate the variable. We want to start getting rid of stuff. One thing we can do is I see x on both sides. So I'm going to remove one x from each side. And I can actually then remove a second x from each side. Now my equation has got a lot easier, okay? I kept things balanced. I removed the same thing from both sides. I now have x plus negative 1 equals a positive 4. So now I want to remove or get rid of this plus negative 1. Now I have two ways that I can do this. One is I could add a pair over here, and then now I have a red that I can remove. Another way that I can also do this is I can simply just add a blue one to each side. If I add a blue one to the left and a blue one to the right, my scale stays the same, but then I now have a pair that is equal to 0 that I can remove. So then we see we have x equals 1, 2, 3, 4, 5. Again, we were at the point where we had x plus negative 1 equals 4. And the way that I solved that was I added one blue, or one hole, to each side. These cancel each other out, or 0 each other out, so the value is 0. So I now have x equals 1, 2, 3, 4, 5. So we can use this again to start solving slightly larger equations.